Hi, Mark. Welcome to the Autoware podcast. It's
Hello,
nice to
Summit.
have you here.
It's a great pleasure to be here.
Mark, we are working with you through the eSync Alliance, and also you are with Excelfore. We are using eSync Alliance OTA technology in our OpenAD Kitworks. So you are involved in both, and also on our working groups and all of our demo preparations. Give us a quick understanding of what you're doing in those organizations, please.
Certainly. I head up marketing for XL4, and XL4 is very active in the eSync Alliance. We were one of 5 companies that came together to create the eSync Alliance. The eSync Alliance now has 30 member companies, but back in the days when we started, we were just 5. I chair the marketing work group for the eSync Alliance. We have currently 3 work groups at the Alliance. We have the marketing work group, which is responsible for promoting the activities of the eSync Alliance. We have the technical work group, which develops the specifications. So the eSync Alliance publishes a standard, a specification for a standard way, a multi-company standard for building an OTA data pipeline. And so the technical work group provides that specification. Then we have a compliance work group, which develops tools and testing methodologies to ensure compliance at a level that creates interoperability. So the model of the eSync Alliance is to build a pipeline out of multiple pieces, and you should be able to take any work done by any one company, and that should be interoperable with the work that's been done by another company, so that it should all work together. And we'll talk a little bit more about the structure. It's a server client agent architecture for the pipeline. An agent from one company should be interoperable with a client from another company, should be interoperable with a server from a third company. And so the compliance work group develops the tools for ensuring that level of interoperability. XL4, we're focused on connectivity issues in the software-defined vehicle. So our initial product line is in-vehicle networking protocol stacks, bringing IP connectivity into the automotive space and doing so in a time-sensitive manner so that it's appropriate for automotive applications. So we provide network protocol stacks. And then the connectivity not only between the devices in the vehicle, but from the vehicle to the cloud. And that's the eSync pipeline. And then some of the cloud services that can be built once you have this kind of connectivity in place, analytical services, data management services, etc. And so we work with automakers and tier ones throughout the world to provide these levels of capabilities into the automotive ecosystem.
Mark, this is a part of the SDV related podcasts. We are also doing racing parts, but this is also a sidetrack fun kind of thing. Uh, before you, I also had podcasts with Casper and then Robert, and very recently with Stefano as well. And we have several pillars that we see, right? The containerization and orchestration, and then OTA is always there. So, uh, can you give us an understanding how the connectivity is a crucial part of the SDV and what kind of values it's bringing? You can also think of it in the sense that how the SDV will also bring value once we realize the goals.
Okay, sure. So I'm not even sure that the industry as a whole has settled on what do we mean when we say SDV. What we mean on our side is a vehicle whose distinguishing features are defined in the software. So, for example, what distinguishes one car from another, one vehicle from another. We've seen this in the work of some of our peers, some of our associates in the eSync Alliance. We've seen this carried all the way to a common chassis being used for different classes of vehicles. So you could imagine a sports sedan versus a family vehicle versus a minivan, uh, all having the same common hardware, and the differing behaviors of these platforms being driven by the software. It can also be more consumer facing. How does do I have the deluxe sound system or the basic sound system? Do I have the performance tuned suspension versus the soft ride suspension? These things can also be defined in the software. And so when you build this kind of thinking into the development of the vehicle platform, you have a vehicle whose distinctiveness is defined in software, a software defined vehicle. Now, there's all kinds of technical issues behind that, as you've described the different pillars to make that possible. And one of them, we believe, is the connectivity. Connectivity within the vehicle and connectivity to the cloud, because software is not static. It's dynamic. It changes in time. If there's anything that we can learn by observing the computing industry, by examining IT industries, it's that the software moves in time. And so we change as an industry in automotive. We change from the model of we built it and that's what it will be for the entire life of the product, to an environment where it's more dynamic, where the product, the vehicle, the car, can actually be improved over time, even while it's in the hands of the consumer. And this is something that the industry hasn't quite gotten used to yet, but is the dominant consumer impact of a software-defined vehicle. The idea that I buy the car today, and rather than having it only decline in time, it can actually improve in time. And I wind up with a better car next year than the car I bought today. And it opens up opportunities for automakers as well to have a continuing relationship with the car buyer. It's not that you bought the car and disappeared until you're ready to buy another car, but that there may be continuing relationships between the car buyer and the car buying public. So there's a lot going on there. But if you're going to deliver on that, you want to be able to update the software in the vehicle. And that's where OTA comes in. I encourage thinking of OTA, over the air, is what OTA means. I encourage the thinking of it, though, as not just unidirectional. It's not just data push. It's not just from the cloud to the car. Once you've built a pipeline and you've built it well, it can be data push and data pull. It's the ability to send data to the vehicle and to send data from the vehicle. And this is important, even if your only purpose is updating the software, because in order to update the software properly, you want to know the state of the vehicle as it is, the state of the edge devices as they are. You don't want to send the wrong software, or you want to have the ability to distinguish in the software you send depending on the state of the vehicle. So all of that guides you to build a bidirectional pipeline anyways. And once you have a bidirectional pipeline in place, then there's far more in value that can be created to make that car buying and car owning experience even better, even more compelling.
It sounded like you repeated some of the findings from the other podcasts too. The functions are defined by software, not hardware. A vehicle can improve and gain value over time, and these are only possible with if you can be able to upgrade the software remotely, right? And also uh, uh, on the understanding of the SDV from your side, you also tied into how the OTA is working a little bit, right? Two ways. You can push the data from vehicle to the cloud, and also you can push the data from cloud to the vehicle to upgrade the software so the behavior of the vehicle is improved, or customers' satisfaction is improved. It could be either way. And uh, just to understand the OTA technology a little bit better. Now we understand that it's working both ways, but can you also try let us understand how you can update the software in batch for fleets of vehicles? Kind of what's the underlying mechanisms that are making sure that you are delivering software in a timely manner, and also you are delivering the software to the right place so you don't hear a lot of user complaints, I guess.
So that's a very good question. And by the way, it's not a surprise to me that you hear some consistency in perspective from some of the other individuals you mentioned. You know, we at least on our side, XL4 and the eSync Alliance, we're very much focused on working together with the industry. And one of the reasons that we, as a company, are so active in the eSync Alliance is the opportunity to work together as an industry to address these issues, because these are large and complex issues. And so collaboration, I think, is key to bringing the industry forward to the next level. So your question, how does it work? Uh, uh, we can we can think of it kind of in the terms of the IoT space, but unique to automotive. So IoT, the Internet of Things. The first generation of OTA for automotive didn't take into account the differences of automotive versus the rest of industry when we talk about IoT infrastructure. And it was, in fact, OTA technologies coming from other industries, predominantly the mobile phone industry, that came into automotive because the thing in the dashboard kind of looked like a big smartphone. The thing in the dashboard, I say, because, well, we used to call it a car radio, and then it became a head unit. And now, depending on the vehicle, there may be some other terminology that's coming into play as well. Looked like a big smartphone. It may even use a smartphone operating system, Android or some version of Linux or something. And so the tools that worked for, my nice small Android device could also be considered for that. But but that parallel fails to recognize a critical characteristic of the automotive industry, and that is, if we talk about the Internet of Things, our challenge is not reaching the car. The car is not the thing. The braking controller is the thing. The backup camera is the thing. The car is a network, or maybe multiple networks of things. It's a system unto itself with networks and buses and dozens of software-driven devices. And so the question is, how do we manage that environment over the air? And so how do we know at the cloud the state of that environment? Because if we have 100,000 cars in the market and each car has 30 or 35 different devices, and each car has gone through its own history, maybe it's gone into the shop, maybe it hasn't gone into the shop, maybe maybe it wasn't available for the last update because it was parked underground. All of these play into, how do I update each and every device that needs to be updated? And so within eSync, the model is it's campaign driven. So we say, for this class of car, this is the software that we want, the version, the state of the software we want to create. I want the braking device to be at version 3. I want the backup camera to be at version 4. I want the ADAS computer to be at version 3.5. This is the state that I want to create. And I've tested, I've gone through my processes of validating, and this is what I want to create. Now, for me to manage 100,000 different vehicles, I need to know the state of every device in every vehicle that might be involved. And this is why we want the bidirectionality of the pipeline. I don't want to rely on historical records for the state of the vehicle. I want to rely on the vehicle actually reporting its state. And so this is an important part of how eSync is constructed. So with eSync, we have agents for the devices. The agents are closely coupled to their devices, and they bring this information and provide it to the client in the vehicle. And the client assembles a tree, and that tree defines its vehicle. And then the client reports its tree to the server in the cloud. And so we know in the cloud the state of each vehicle and the state of each device in each vehicle, so that when we say, this is the state we want to have, then we know what needs to be sent to each vehicle to achieve that state. And so this is how the process works for delivering the software to get to an environment where the vehicle has the right software to meet the conditions that we set as the campaign. And it's the nature of the eSync pipeline to achieve this.
Yeah, to reach out to all those different devices, you need a very granular understanding. It sounded like a huge state machine, right? You know what's happening on the field, and also you know which version to be uh, uh, downloaded at the edge on the vehicle and everything. So it reminds me how you need to move the data to uh, I'm getting to the architecture of the thing, right? If you cannot just get access to a gateway and then upgrade the entire thing at once, you probably need the smaller components that are accessible to you, so you have a better understanding, like a fine granular understanding of that huge network of devices in every vehicle. And also on the other side, not only the automotive, right? Because your technology is supposed to work on the cloud, so the validated packages can be pushed. So how can you work in the cloud at the edge and also maybe in virtual devices as well? That's landing on the containerization part, right? From your end.
It so the granularity is really the challenge that is so well addressed by the eSync standard and the eSync data pipeline. And the model is to encapsulate the unique characteristics of the edge into the agent. So this is part of why we have this structured approach where we've built the extra layer within the vehicle and standardizing that. Now, when I say standardized, it doesn't mean, oh, there's one way to do an agent that works with everything. Far from it. The edge is too diverse. So we have some environments, some cases in our edge where there's a small microcontroller or a processor running a small RTOS, and it may be on one form of bus or network, say a CAN bus, versus we have high performance computing platforms with hypervisors and multiple virtual machines, and the different virtual machines may be running different operating systems, or even if they're running the same operating system, they may be running different processes that need to be isolated. This is an enormous span, and it may be 5 or 8 or 10 different operating systems, not in one vehicle, but across the industry. 2 or 3 or 4 operating systems in one vehicle, different processor platforms, different buses or networks. How do we bring all of that together into one way of doing things? And we do that through the provisioning of agents. And the agent can be customized on the device side to encapsulate the unique requirements of that edge, whether it's a virtual machine or an actual hardware platform, whether it's a small RTOS or a full POSIX operating system. The agent is written to work and do its job with that edge. So on the edge side, very customizable, but on the client side, fully standard. So the client agent correspondence is a standard set of messaging and a standard set of tasks. And the net result is from the cloud to the vehicle, we can build a common way of working and corresponding. And to the client, it's just an agent, and the client knows how to talk to an agent. And whether it's a classic AutoSAR device or a micro velocity or Erica or some small RTOS or it's um, a Linux virtual machine on a QNX hypervisor. To eSync, it's an agent, and eSync knows how to talk to an agent. And the agent then encapsulates the uniqueness of that edge, almost like you can think of it almost like an abstraction layer. Now, with this structure, the pipeline can deliver to a workbench system, a vehicle on a test track, a vehicle in the field, a virtual twin, a digital twin of the vehicle in the cloud. It 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 works the same way in all of those cases. We know how to find a client. The client has a tree that it's reported. We know what software to issue to that tree to bring it to the state that we want. And it is the agent that works at the device level to determine what it needs to do to install this software in that device. And through this process, you can use the same pipeline, so you're not injecting a variable late in the development process. You can use the same pipeline throughout the development process, throughout the validation process. You validate it with your digital twin in the cloud. You validate it with your bench rig setup. You validate it with your test vehicles. You're ready to go to your production vehicles. You're using the same distribution and installation mechanism across that spectrum, so that you don't validate with one installation and then use a different installation when the time comes to go out to the field. And so this is, we think this is an important part of ensuring the robustness and the reliability of the whole CI/CD development process. That you're not injecting new variables late in the process. You're remaining as consistent. You're reducing your variables as much as possible, keeping everything constant on the delivery and installation side. And this is seminal work. This is the kind of work that can't be done by any one company. It's one of the reasons that this collaborative model is so important. We've worked with the ARM and the SOFI SIG on containerized software. We've worked with AWS on their digital twin in the cloud, and it's not a theoretical model, it's a practical model. It's actually built through execution and through the working proof that we've built this and it works. And so this is part of what we'll be showing in just a month now at CES is the joint development, the fruit of the labors now of 2 years of effort between these different companies and organizations. The Autoware Foundation, of course, being a big part of that, so I should give credit there as well. Because to say I can do the delivery of software without the software, I can't prove it. And the autonomous vehicle stacks are among the most complex software that the automotive industry is going to be dealing with. And it is software that is moving faster than almost any other software in the vehicle in terms of its progression, in terms of its development pace. And so having the acid test, if you will, the primary challenge, containerization, which is coming to us through the eWall layer and the SOFI SIG, the Autoware Foundation stacks, the AWS infrastructure, both for the digital twin in the cloud and the distribution on a global basis to the edge. All of that together is something that no one company could be making that progress at the level that we're able to make it through this collaboration.
Yeah, so the in the first part, if you remember, I asked about the SDV values. You repeated all the other people, but you omitted the collaboration, and then you brought it a little bit later in the conversation for the second time now, right? So the collaboration is key was a very important takeaway when I was talking to Robert, of course. And then, as you mentioned at the CES, we are hoping to show that very collaborative demo. I don't know how many organizations involved now. It's a very nice collaborative effort. Um, Before I ask a little bit particular things about the CES demo, because I know your affiliation to Covisa as well, I want to ask one more question. And this is kind of stemmed when you said at the eSync, you have three kind of working committees, right? You said about the compliance. So I was going to ask about some generic understanding because we are talking about autonomous vehicles here, and also we are talking about the open source software stack there. So my mind was going for asking cybersecurity aspect of this because people probably will look for something related to cybersecurity in this conversation. And then also I didn't have this idea originally, first of all, but in your compliance committee, are you working with the regulators and everything? Because that's a hurdle, right? Do we expect OTA technology to make this also possible and a little bit streamlined?
We do, and again, it's one more reason for the value of collaboration, and I might add, distinct from collaboration, the value of standardization.
Open
Uh,
standards, right? Yeah,
well,
because yeah.
it's not just the openness of the standards, but if each company has to individually work its way through all of the regulatory requirements, this is a very heavy burden. And when I say each company, I mean not only each automaker, but each tier one and even each tier two. This is a very heavy burden. When you work with a standard, if the standard has been brought along with this in mind, you benefit from the work that's done in the development of the standard when you take the standard and you use it. So the dominant regulatory requirements that we see developing is the UNECE WP29 regulations. It coming out of Europe, but being adopted in other geographies as well around the world. And in particular, what we're speaking of here, the topics we're speaking of among the WP29 regulations, it's R155 and R156. That's CSMS, Cybersecurity Management Systems, and SUMS, Software Update Management Systems. And so these are the things that we at the eSync Alliance have worked very hard to ensure that what we're doing is giving the tool set to be in compliance. Now, these regulations require more than just how do you do OTA, it's how do you manage your business, how do you manage your software development flow. So there's more that needs to be done, not just adopting eSync, but that eSync provides you the toolkit. eSync itself fits into the R155 and the R156 frameworks, and it gives you the toolkit to help you on the rest of your requirements that come out of those regulations. I might choose an example in R156 in SUMS that you need to have a record available for periodic inspection by the regulatory agencies that shows the history of the software in each device, in each vehicle, so that you can know that the software that's in the ADAS computing platform in this vehicle in front of you now is the correct software that was validated with the software that's running the backup camera or the LiDAR or the radar. And so that you've created an environment where that can be traced and tracked, and inspection can generate that. And so one of the things that eSync does, as an example, is it provides logs of every eSync transaction, including the installation of any software into any device in the vehicle. And in sums, in WP29R156, you have what is referred to as the RX SWIN, the regulation X, whichever the regulations are that are covered, software identification number. And so you should be able, as an automaker, you should be able to provide evidence for the periodic inspection, for the regulatory agency. You should be able to provide evidence how the software was validated in your test and development environment, and show how it was sent and installed, and the traceability of that whole path. Well, eSync is only the send and install, but you get all of that log information so that you can complete your log from your CI/CD environment, from your software development and validation process into the distribution and installation process, and show the continuity all the way to the installation in every edge device in every vehicle in the fleet, every vehicle in the field. So, to build that scenario out, standards are very helpful. Doing things in a standard way, very helpful. Standard way across the edge devices, standard way across the distribution mechanisms, and standard way across the different vehicles in your fleet, different models and different, they may have different internal architectures because they were produced in different years, or you may have multiple models in your product family. They may have different edge device sets. So I've got the braking controller from one company in Model A, and I've got a braking controller from another company, or a different model of braking controller and a different in Model B. They should all have the same construct for how you do your processes of installation of software. And this is what standards give you. And this is what eSync offers, because today there is no other approach in the industry that gives you one way of doing it for an Android device and an AutoSAR device and a VxWorks or virtual machine, a Linux device, a virtual Linux device, versus a device using, micro velocity or some other small RTOS. All of this can be done in the same way and in a standard way by adopting an eSync compliant solution. And this helps greatly with regulatory compliance.
I think viewers can watch especially this part over and over to understand how to get a good understanding of regulatory compliance as well. Thank you for that very nice and detailed explanation. Mark, before we wrap up, as we did it last year at the CES, we had several OpenAD demos in the show floor, but also we had the OpenAD demo at this adjacent event from Covisa, and this year we will also have the same arrangement. Can you tell us what we can expect from eSync Alliance and from that demo?
Certainly. So the Covisa event, for those who are not familiar with it, Covisa is working. They have an initiative, VSS and VSC, to try to standardize the data in the vehicle, the data structure, the data format, the data syntax. The eSync Alliance building a pipeline for the data, of course, we're very concerned with that. So we have the Alliance has a liaison relationship with Covisa, a formal relationship, to contribute to and draw from the VSS, and to do proof of concept work to make sure that this data pipeline concept works with that. So we have a very good relationship with Covisa, and we take part in this Covisa event every year. It's a pretty good event, and if our viewers here are not familiar with it, I encourage you to look into it. This year it will be January 9th at the Bellagio Hotel. It runs in the evening after the CES show. And it is both a networking event and a showcase. Showcase meaning there will be displays set up. So the eSync Alliance will have a display, and at our display we will have the system that you and I have been discussing, which is a benchtop implementation of the Autoware Foundation OpenAD stack. We'll have a benchtop system running the autonomous software from the Autoware Foundation, and we will be doing changes to it. Now, this is a containerized software environment. It's built on eWall, the Sophie eWall construct, and it's containerized software, and we'll be using the AWS cloud, and we'll be doing live over-the-air updates to some of the bigger pieces of the Autoware stack. In particular, we'll probably be showcasing the planning modules in the Autoware Foundation, and providing incremental updates to the planning capabilities of the platform for how the driving should be taking place, how the vehicle maneuvers through traffic environments. And we'll be doing that both using a digital twin in the cloud as well as the physical instantiation on the workbench. So we'll have a variety of edges. And to eSync, I mean, this is what it's supposed to do. And so you can come and see how it actually does that. To take, I got version 1 and I've got version 2, or version X and version X+1. And how do I see the distribution at work, that I can check the digital twin in the cloud to see if my version X+1 is working better in the scenarios that I was not succeeding with version X. My X+1 is working better. It's navigating its way through the traffic environment better. And I can see that in my digital twin in the cloud as part of my development environment. Then I can take that and install it in my edge. And now I'm ready to go off and do further testing in the actual world. So this is a part of what the collaboration between our organizations have created. And so this is what we'll be showing. It'll be there and it'll be live. And bring your skeptics glasses and let's take a look at it and watch it work.
Thank you, Mark. I'll be at CES too, and we will be doing a lot of news gathering from those demos as well. Hopefully, we will give a lot to the audience to enjoy. And Mark, thank you for joining to this episode of the Autoware podcast. Now we covered the OTA part, and we will continue with the DevOps tools. So everything is kind of fitting into each other at the end. It was not too revealing when you explained the demo, but we will soon reveal the whole understanding of the demo to the audience soon. But I think we covered a lot, and it was very informative. And thank you again for coming to the podcast.
My great pleasure, Simon. Thank you very much.
Hope to see you again soon here.
All right.
Take care now.